Here we've got these three people working at some firm, and we're given some information about who worked longer than whom, and one of them is a difference and the other is a ratio. And so I'm tempted to draw a number line starting from 0 because you can't work a negative number of years at a firm, so these numbers must all be positive. And so I draw a number line and just kind of place these three individuals on the number line based on the information provided. S followed by G followed by J. Now the difference between S and G we know is 4 from the free info. And we also know that J is exactly twice as far from 0 as G is. So whatever distance we put between 0 and G, we'll have to double that to get to J. Now when we look at these statements, something really interesting happens here, because if you know statement 1, meaning we know the distance from S to J is 9, we can infer the distance from G to J is 5. Because after all, we knew that the distance between S and G is 4. But here's what's so interesting. Statement 2 tells us the very thing that we inferred from statement 1. And this works in the other direction as well. Had we started with statement 2 and we saw that the distance between G and J is 5, and we know from the free info that the distance from S to G is 4, we could have inferred statement 1, which says that the distance from S to J is 9. So this is a situation where the statements are inferentially equivalent, and I explain this in the second section of my book, which you could actually read for free on quantreasoning.com, where if the statements imply one another, we can eliminate answer choices A, B, and C without even reading the question. That's kind of amazing. So in this case, what's the answer? Is it D or is it E? Well, let's figure that out right after the intro. So to answer this question, we basically just need to know where 0 exactly fits on this number line. In other words, how far to the left of S or of G is 0. But from either of these statements, we can infer that the distance from G to J is 5, and we know from the free info that J is twice as far from 0 as G is. So if that distance between G and J is 5, then the total distance between 0 and J is 10, and now we can infer anything we want about the number of years any of them has worked at the firm. So it turns out the correct answer here is D. If you found this video useful, go to quantreasoning.com for a lot more where that came from. You should also click that like button and let me know in the comments below what you'd like me to make future videos about. And of course, if you haven't yet subscribed, go ahead and do that and click that bell below so you get notified about future videos. See you next time.